guys, welcome back to Wong Chemistry channel. For this video is the part 1 video of your Chatelier principle. The effect of concentration to your system that is already equilibrium by using the Chatelier principle. We are going to see how can the concentration affect the equilibrium position. Alright? First and foremost, I think it's very important for you to understand what is actually Chatelier principle about. Okay? Chatelier principle stated that if a system is at equilibrium, so right now, your system is already at equilibrium, okay? And when your system that is already at equilibrium is subjected to an external stress, and external stress that we mean over here, we also call it as a disturbance, okay? Whether it's an external stress or disturbance, they represent the same thing. Your system that was at equilibrium right now having some external stress or disturbance, so your system will try to adjust itself to re-achieve the equilibrium. At the end of the day, what is the most important thing in this video is we want to maintain the equilibrium of your system. No matter what changes that we are doing to the system will try to maintain the equilibrium. That is what we are going to do, okay? And like we say, today's video is about concentration. Therefore, your external stress or your disturbance today will be about concentration only. So if you are changing the concentration, it will definitely affect the system that is already at equilibrium. So what will your system do? How can your system adjust itself? The equilibrium position in the system will tend to shift in a direction that will reduce the effect of the change or the disturbance. So right now, you are having a disturbance and your system will try to reduce the effect of disturbance by going against the disturbance. So what Chatelier principle is trying to tell you over here is the equilibrium position or your system will try to decrease or will try to minimize the effect of your external stress or disturbance that you put into the system that is already at equilibrium. So let's say, if my disturbance over here is the increase of the concentration of your reactant. So right now, the concentration of your reactant increase. So what do you think your system will do? So according to Chatelier principle, the system will go against the disturbance. Alright, so that we can minimize or reduce the effect of the disturbance. So if the disturbance is increase the concentration, so everything right now is at equilibrium, suddenly your reactant increase. So what will the system do? How will the system react? Simple. The system will try to decrease the concentration of your reactant. So in here, it's as simple as if your disturbance is increased, your system will try to decrease it. The same thing goes to the vice versa. If my disturbance today is to decrease the concentration of my product, let's say. So if my disturbance is decrease the concentration of product, what do you think your system will do? Your system will go opposite, will go against your disturbance. The system right now will increase the concentration of your product. See that? So that is what Chatelier trying to tell you. We are going to maintain the equilibrium. We are going to re-achieve the equilibrium by going against the external stress or disturbance. Okay? We want to make sure our system is at equilibrium no matter we are having what kind of disturbance. Alright? At the end of the day, the only things that the system will do is to maintain the equilibrium. So whatever is your disturbance, the system will go against the disturbance. Alright? It's as simple as that. Okay? So I have 4 steps to guide you through on how to answer the Chatelier principle. The first one, you must identify your disturbance, or we call it as your external stress. You need to know what is your disturbance. You need to know what is your external stress. Okay? Second, you need to know how can the system re-achieve equilibrium. Okay? The third one, Based on the Lee-Chatelier principle that we have discussed, you will then need to decide which direction will the equilibrium position shift from and to. Okay? So we want to maintain the equilibrium. We should be going to the left or we should be going to the right. There is only two directions, from the left to the right or from the right to the left. Depends on the question. Alright? And last but not least, because of the changes, what will happen to the concentration of the product and reactant in your system? Okay? This is the 4 things that you need to have when you are answering your Lee-Chatelier principle question. Okay? Knowing that generally your reactant is on the left, while it's a reversible reaction and your product is on the right. Okay? So if we are shifting from the reactant to the product, so the green color over here moving from your reactant to the product means we are shifting from left to right. So if you are going to shift from left to right, the concentration of your reactant will decrease because we are using the reactant changing to the product. And vice versa, the concentration of the product over here will be increased because you are producing the product. Okay? Vice versa, if we are shifting from the product to the reactant, what will happen? So if I'm having from the product to the reactant, that means we are shift from right to the left. So since we are shifting from the right to the left, that means my product over here will decrease. The concentration of the product will decrease. Vice versa, the concentration of your reactant over here will increase. We will be forming more reactant because we are moving towards the reactant. Can you see that? So you are moving from the product to the reactant. So the product concentration will decrease. The reactant concentration will increase. So one of the most important thing is you need to know which direction you are shifting from and to. You are moving from the left to the right or you are moving from the right to the left. It's easy. Always remember, Lee-Chatelier principle means the system will go against the disturbance. And at the end of the day, the system is trying to maintain the equilibrium. Okay? So, if the disturbance right now is increasing the concentration of your reactant right now. So, I have my reactant and product. So, my disturbance right now is the concentration of my reactant increase. I have a lot of my reactant in my system right now. So, what will the system do? Simple. In order to re-achieve the equilibrium, the system will decrease the reactant. Alright? We have too many reactant right now in our system because we are increasing the concentration. That's why the system is no longer at equilibrium. So how can we re-achieve the equilibrium? Simple. We decrease back the concentration of reactant just now. Okay? And how can I decrease the concentration of reactant? Quite simple. The concentration of your reactant is too much. So when it's too much, how can we solve this problem? Or how can we decrease it? Simple. Use it. So when you decided to use your reactant, then the concentration of the reactant will decrease. Then we can re-achieve the equilibrium of the system. So, according to Lee-Chatelier principle, the equilibrium position will be shifting from left to the right. Okay? So when we shift from the left to the right, your reactant will be used. Then the concentration will decrease. So concentration decrease is what we want. Okay? As a result, what happened? As a result, the reactant concentration will decrease. Okay? And this is what we want. Why do we want this? Because your disturbance is increasing the concentration of your reactant. Which means in your system, I have too many reactant. So I need to reduce the reactant. Okay? Other than the concentration of the reactant decrease, your product over here will increase. Why the product will increase? Simple. Because your equilibrium position is shifting from the left to the right. So when it's shifting from the left to the right, the product over here will be formed. So when the product over here will be formed, the concentration of product will increase. Alright? Simple, as easy as that. Always remember, you need to know what is your disturbance before you need to know what your system will do. So your system will re-achieve the equilibrium by decreasing the concentration that you increased just now. Okay? And we need to determine that it will be shifting from where to where. And at the end of the day, which concentration decrease and which concentration increase, or vice versa. Okay? Simple. Next, the disturbance over here, alright, another disturbance, is decreasing the concentration of reactant. Still talking about reactant, but right now we are decreasing the concentration of reactant. In the other words, your reactant right now, the concentration decrease. When the concentration decrease means you are having not enough of your reactant. And that is your disturbance. Your disturbance is the concentration of the reactant decrease. You are having not enough of your reactant. Okay? So, at the end of the day, what will the system do? In order to re-achieve equilibrium, the system will increase the concentration of your reactant. Alright? Because your reactant concentration right now is not enough. So when it's not enough, your system will try to increase the reactant concentration. And since your system want to increase the concentration of the reactant, therefore, according to Chatelier principle, your equilibrium position must be shifted from the right to the left because we want to increase the concentration of the reactant. Agree? So, what will happen when the equilibrium position is shifting from the right to the left? Simple. Your reactant over here will be produced. Alright? And that is what we want because we want to increase. Your system want to increase the reactant. So, we must be shifting your equilibrium position to a direction where your reactant increase. Okay? And to increase the reactant is as simple as you need to produce the reactant. Okay? Bear that in mind, your disturbance right now is removing the reactant or decreasing the concentration of your reactant. So your system, alright, will try to increase the reactant again. Bear that in mind, the Chatelier principle, your system will always go against, alright, will always go opposite of the disturbance, okay? So that the system can re-achieve the equilibrium, alright? And since your equilibrium position is shifting from the right to the left, from the right to the left means on the right, your product is used. When your product is used, what happened to the concentration? The concentration of the product will definitely decrease. As a result, the concentration of the product will decrease. And when the concentration of product decrease, guys, what happened to the concentration of your reactant? The concentration of your reactant will then increase. Alright? As simple as that. Okay? Easy. Next, something very similar, but now we are looking at the disturbance that happened to the product. What happened when you try to increase the product? Okay? So your external stress or your disturbance right now is trying to increase the product. So what do you think your system will do when you have too much product? Okay? Because right now your disturbance or your external stress is increasing the concentration of the product. So your system will do something very simple. In order for your system to re-achieve equilibrium, your system will do something very simple. Your system will decrease the concentration of your product. As simple as that. Okay? Because your disturbance is increasing the product and therefore in your system that is already at equilibrium, having too much of your product. So what will the system do? Decrease the product. Then I re-achieve the equilibrium. But the biggest question is always, how can I decrease the product? Bear that in mind, to decrease something, you need to use it. So, are we going from the left to the right or are we going from the right to the left? Look at it. Your product right now is having too much. We need to use the product. So, to use the product, we need to move from the product to the reactant. Can you see that? So, when you're moving from the right to the left, Okay? Your system is using the product. So when your system is using the product, what happened to the concentration of product? The concentration of product will decrease. And that is what your system wants to re-achieve equilibrium. Therefore, according to Chatelier principle, the equilibrium position right now will shift from your right to the left. Okay? And as a result, what will happen? Because the system is using the product, therefore, the concentration of the product is based on what we want. The concentration of product will then decrease. And since the concentration of product decrease, we are moving from the right to the left. Your reactant will be produced by the system. Okay? When the reactant is produced by the system, what will happen to the concentration of your reactant? Simple. We are producing the reactant. So the concentration of reactant will increase. Simple? Alright? So always remember, in the Chatelier principle, it's as simple as maintaining the equilibrium. And how can I maintain the equilibrium? The system will go against the disturbance. That's it. When the disturbance is increasing the product, your system will decrease the product. Okay? And last but not least, your external stress over here or your disturbance over here is as simple as decreasing the concentration of your product. So your disturbance, your external stress is the product concentration decrease. When the product concentration decrease means that the amount of your product is not enough. So when the amount of product is not enough, what will your system do? Simple. Your system will increase the concentration of your product. Okay? Always remember, the system will only do one thing. The system will always go against your disturbance. Okay? So, based on the Chatelier principle, where do you think your equilibrium position will shift so that the system can increase the product? Increase over here means you need to produce. Agree? So when I want to produce the product, I will definitely shifting from the left to the right so that I can produce the product. Agree? And since we are shifting from the left over here to the right, and for sure what we want is your product concentration increase. So as a result, the concentration of the product will increase. And by that in mind, it will increase because we produce the product. Can you see that? We are going towards the product. So we produce the product. While for the reactant, we are using the reactant. So when we are using the reactant, when you are using your money, what happened to the money? The concentration or your money will decrease. So the concentration of your reactant will decrease. Okay? And all this is because of one disturbance towards your system that is already at equilibrium. I'm living happily ever after in the equilibrium. Suddenly, I'm having some external stress. I'm having some disturbance that disturbing the equilibrium of my system. So, your system will only do one thing, counter-attack. Your system will go against the disturbance so that the system can maintain or re-achieve the equilibrium. Okay? So right now, I hope you understand the Chatelier principle in the effect of concentration. Next, just a kind reminder, you should know that the changes of concentration of solid and liquid, the equilibrium position shall remain unchanged because both of your solid liquid will have a constant concentration. Bear that in mind, your solid and liquid concentration will not change. When the disturbance is changing the concentration of solid or liquid, your equilibrium position will remain unchanged. Okay? Next, the changes that you make to the concentration in the system, the Kc will still remain unchanged at a constant temperature. Bear that in mind, Kc, Kp will only be affected by temperature. So changing of concentration will not change the Kc or Kp value. Okay? Please remember that. So let's look at the first example on how the concentration can affect your equilibrium position of a system. Consider the following reaction in a 2-liter container which already reached equilibrium. Bear that in mind, your system right now is already at equilibrium. But by using the Chatelier principle, state the shift in equilibrium position of the reaction if, let's do the A over here. I have my PCl5 removed. So what is meant by PCl5 remove? PCl5 remove means the concentration of your PCl5 decrease. That is what we mean by the word remove. Okay? And bear that in mind, this is your disturbance that you put into your system that is already at equilibrium. So your PCl5 decrease is a disturbance over here. Since this is the disturbance given in the question, what would the system do to re-achieve the equilibrium? The system will increase the PCl5 concentration because the concentration of PCl5 right now decreased in the disturbance. So the system will always go against the disturbance to maintain the equilibrium. Okay? And how can I increase the PCl5? Let's find where is your PCl5. That is my PCl5. So your system right now want to increase the PCl5. Increase over here means we need to produce more PCl5. Agree? So produce means we will be moving towards PCl5. Then only I can produce a lot of my PCl5, right? And based on this concept, you know that you will be shifting from the left to the right. Can you see that? So according to the Chatelier principle, the equilibrium position will shift from left to right. And as a result, what happened to the concentration? Look at it. We are moving to your PCl5 over here. In the other words, guys, we are producing PCl5. As a result, the concentration of your PCl5 over here shall increase. See that? Alright, because we are producing it. Since we are producing your PCl5, alright, the we I mean over here is the system. So the system right now is producing PCl5. But how about PCl3 and Cl2? We are moving from the left to the right. Your equilibrium position is shifting from the left to the right. Can you see that? And since we are shifting from the left to the right, which means your PCl3 and your Cl2 is used by the system to produce your PCl5 just now. So when it's used by the system, what happened to the concentration? We use them, guys. Therefore, PCl3 concentration and Cl2 concentration, both of them will decrease. Alright, both of the concentration will decrease because it's used by the system to re-increase, to produce more PCl5. Simple. Alright? Next, let's try question B. Question B stated that your chlorine gas, Cl2, is removed. Is removed means what? The concentration of Cl2 decreased. That is what we mean. Alright, and bear that in mind, in the question right now acts as a disturbance or your external stress. So your disturbance right now is your concentration Cl2 decrease. So we are going to focus at your Cl2. Alright? The disturbance is somebody removed the Cl2. So your system that is already at equilibrium suddenly losing its equilibrium. Why? Because Cl2 decreased. So how can the system maintain the equilibrium? Simple. The system will increase the concentration of Cl2. Alright? I'm losing Cl2, but it's fine. The system will try to increase the Cl2 so that the equilibrium is re-achieved. Okay? Bear that in mind. We want to re-achieve the equilibrium. We want to make sure your system is always in equilibrium. Okay? So according to the Chatelier principle, the equilibrium position will then shift from where to where. Since the system want to increase the Cl2, that means we need to produce more Cl2. And how can I produce Cl2? Simple. We are moving towards Cl2. Can you see that? We'll be moving to Cl2. Okay? Produce more Cl2 or moving to Cl2 means we will be shifting from the right over here to the left. Agree? So we are shifting from the right to the left. because your Cl2 is on the left, and since I want to produce more Cl2 to achieve my equilibrium, so we will be shifting to the left, okay? As a result, what happened to the concentration of PCl5 and what happened to the concentration of Cl2? Simple. We are moving towards your PCl3 and your Cl2, alright? We are moving from the right to the left. As a result, your concentration of PCl3 will increase. The concentration of Cl2 will also increase because we are moving towards them. So when you're moving towards your Cl2 and PCl3, means we are producing both of them, okay? When we produce them, that means the concentration increase. Vice versa, we are moving from PCl5. When we are moving from PCl5, we are using it, alright? Since we are using it, the concentration of PCl5 will decrease. Okay? Simple, easy. That is how we answer Le Chatelier principle question. So the very first thing that you need to know is your disturbance. What is your disturbance? Your system will always try to go against the disturbance to re-achieve the equilibrium, to maintain the equilibrium. Okay? Always remember that. So let's try another question very quickly. You have your example 2 over here, talking about your Hi gas, your I2 gas, and your H2 gas. So everything will be involved. By using the Le Chatelier principle, state the shift in the equilibrium position of the reaction if Hi is added in. So Hi is added means the concentration of Hi right now increase. And bear that in mind, that is my disturbance. Alright? Since the disturbance is increasing the concentration of Hi, what do you think your system will do? Your system will try to decrease the concentration of Hi so that we can re-achieve the equilibrium. And how can I decrease the Hi? Decrease the Hi means I need to use the Hi, right? And how do I use the Hi? Simple. That is my Hi. We need to use the Hi to decrease the Hi. Therefore, your equilibrium position must be shifting from the left over here to the right. Okay? Bear that in mind, the left-right that we mean is before and after the arrow. Okay? So your equilibrium position right now will shift from the left to the right. And since we are shifting from the left to the right, as a result, what happened to the concentration of your Hi? We are moving from the left to the right. So we are using your Hi, right? And since we are using the Hi, the concentration of Hi will decrease because we are using the Hi. And then what happened to the concentration of I2 and also the concentration of your H2? And since we are shifting from the left to the right, so when we shift to the right, we are actually producing your I2 and your H2. So what happened to their concentration? Their concentration will definitely increase because we are shifting from the left to the right. Simple, easy. Alright. Next, let's try question B over here. It's the same equation, same question, but it's the B. Okay? Hydrogen gas is removed. Hydrogen gas is removed means the word remove represent the concentration decrease. And by that in mind, in the question, that is a disturbance. Alright? The question is right now giving external stress or making changes to your system that is already at equilibrium. So that is our disturbance. What will the system do? Simple. The system will then increase what you have decreased. So the system will increase the concentration of hydrogen gas. As simple as that. And how can we increase something? Simple. We produce the hydrogen gas. When you produce the hydrogen gas, you increase the concentration. Okay? And your hydrogen gas is located over here, and I want to increase the concentration of it, or I want to produce it. Therefore, we will be shifting from the left to the right over here. Bear that in mind again, the left-right is before and after the arrow. Okay? So, according to Le Chatelier principle, the equilibrium position will shift from the left to the right. I hope you agree after so many examples, okay? And since we are shifting from the left to the right, so this guy will be used and over here will be produced because we are shifting from the left to the right. As a result, the concentration of HI will decrease because we are using it, alright? While the concentration of H2 and the concentration of your I2 over here will increase because we are shifting from the left to the right. We are producing the I2 and H2. Okay? Simple. Always remember one thing, your system is already at equilibrium and then you have someone making changes to your system. So your system will always go against the changes, go against the disturbance so that your system can re-achieve the equilibrium. Okay? As simple as that. Let's look at one more example over here. So, consider the following reaction in equilibrium by using Lee-Chatelier principle. State the shift in equilibrium position of the reaction if water is removed. Let's find where is our water. It's a reaction between your carbon dioxide reacting with your hydrogen gas, forming your water over here and also your carbon monoxide. So, I hope you realize the problem over is your water right now is a liquid in this reaction. So, your water is a liquid. And we know that the concentration of a liquid is remain constant. Agree? Bear that in mind, your liquid concentration will not change the equilibrium position. Okay? Because the concentration of a liquid remain constant. As a result, the equilibrium position of the system will remain unchanged. Okay? Bear that in mind, when it's a liquid, the disturbance happen is the concentration of your liquid or solid, the equilibrium position will remain unchanged. Okay? It won't change anything because the concentration of a liquid or solid is constant. I hope you remember this. Okay? One more last example for this video. Haber process is the formation of ammonia, that is my ammonia, in gas by reacting hydrogen gas and nitrogen gas as given. You have your nitrogen gas in gas, your hydrogen gas also in gas. Perfect. Slightly different question over here. The question is asking you, suggest how can production of ammonia increase? Okay, so we want to increase the concentration of ammonia. But guys, look at here. Suggest how can production of ammonia increase? This is the result that the system want. Okay? This is not a disturbance. You are the one that need to suggest the disturbance. You need to suggest the disturbance that you can make to increase the concentration of ammonia. In the other words, at the end of the day, your equilibrium position must be shifting to ammonia. Okay, because we want to produce ammonia. The result that the system wants is to increase the concentration of ammonia. So at the end of the day, everybody must be shifting from the left to the right. Okay, so you are the one that need to suggest the disturbance. What disturbance that you can make so that your equilibrium position is shifting from the left to the right, and also the concentration of ammonia would increase at the end of the disturbance. Okay? So the very first disturbance that I can suggest is as simple as decrease the concentration of ammonia. Alright? Bear that in mind. The disturbance and the system is always going against. So right now, your system want the concentration of ammonia to increase. So what will the disturbance do? The disturbance will go against it as well. So the disturbance must be decrease the concentration of ammonia. When the disturbance is decreasing the concentration of ammonia, then your system will try to increase it. Can you see that? So every single disturbance that you suggest must result in your system producing more ammonia. Okay? So the first one that I suggest, decrease the concentration of ammonia. The second is definitely increase the concentration of nitrogen gas and also increase the concentration of your hydrogen gas. Okay? So if your disturbance is increasing the concentration of nitrogen gas and hydrogen gas, that is the disturbance. Over here, what will your system do? Your system will try to decrease them. Alright? When the system try to decrease them, the system will use them. So when we use them, we will then moving from, okay, your nitrogen and also your hydrogen gas. So you can see that if the disturbance right now is relating to your nitrogen gas and your hydrogen gas, and the disturbance is increasing them. So I'm having a lot of this. So what will the system do? The system will decrease them by shifting from the left to the right. And the moment you shift from the left to the right, and your ammonia will increase. Can you see that? So another type of question over here, the question is not giving you the disturbance, but in fact, the question is asking for the disturbance, alright? And your disturbance must result to one thing, the concentration ammonia increase. So every single disturbance that you suggest over here must result to the concentration of ammonia increase. Okay? Then your disturbance that you suggest is correct. Okay? And that's it about your system and the disturbance. So always remember what Le Chatelier principle said is only one thing. Your system is at equilibrium. There is some changes that cause the system to lose its equilibrium. So what will the system do? The system will go against the changes, or the system will go against the disturbance to re-achieve the equilibrium. At the end of the day, what the Le Chatelier principle trying to do is to maintain the equilibrium of your system. So your system will always go against the disturbance. Alright? So that's it. So I hope this video able to help you to understand Le Chatelier principle, the effect of concentration. Make sure you like the video, subscribe to my channel, and thank you for watching. I'll see you again in the next video.
TunePocket.com